Good morning, everyone. We're going to get started here. Please welcome Angela and Brian. They will be talking about Dependency Hell, a library author's guide.
Yay. Good. Perfect. So I'm the Brian one in the pair. So this is a talk about compatibility issues that can occur when you're packaging Python libraries, like for distribution on PyPl or internal repository, if your company has one of those. This might be useful for people who are just kind of interested in packaging but not doing that explicitly. But if you're not really familiar with packaging, this talk will probably move a bit fast for you. So that's just a bit of a warning. So we're going to talk about just do a bit of an overview about the problem. Then Angela will dive into some of the technical details. We're going to talk about kind of all the packaging dependency problems that can happen, and then finally end with some best practices. So all the examples that we're going to show you, by the way, are real ones, or at least they were real at the time I was making these slides. So let's imagine that I'm going to do some data science stuff. I'm going to use TensorFlow for my machine learning stuff, and I'm going to use Apache Beam for my kind of data flow. So I make my new virtual environment, and I go pip install Apache Beam TensorFlow, wait a couple seconds, and then I get this crap. I'm in dependency hell now. And the reason this is hell and not just another like minor little inconvenience like you hit all the time when you're programming is I seriously do not understand this error message at all as a user. So let's see what it says. So it says TensorBoard. So it's good that it starts up with a word that I don't understand, because I don't know anything about TensorBoard. I didn't ask for TensorBoard. It's not on the list of things I asked for. And it says a version number that I don't care about because I didn't care about TensorBoard overall. And it talks about protobuf, which I also don't care about because I didn't ask for protobuf. And then it falls out, it'll say I have protobuf version 3.3.0, which is incompatible. But I don't, incompatible with what? Like I didn't ask for it and I didn't ask for anything that uses it. So as a user, I have no idea what this is telling me. And even as a packaging expert, okay, let's imagine I fully understand what this is saying to me. What am I supposed to do about it? So like this isn't a syntax error I can fix. Like my choices are kind of like I can assume that someone on the Apache Beam team or the TensorFlow team is just a liar, and that this is a bogus error, and just ignore it, and that would just be kind of YOLOing the entire situation, and hopefully it won't explode on me. Or I could just say, you know, look, I've heard TensorFlow is kind of good, but I just can't use it for this project. Like, I just can't use it. It's incompatible with this other thing I need. So yeah, we're just done with this. And like, so neither of those solutions is at all reasonable for the user. So this isn't some theoretical thing. This is an actual problem. And Angela and I actually both work for Google, and we started looking into this because our customers were complaining, hey, we get errors like this, and we don't know how to fix them. And this isn't just a Google project. If you look at the top 100 PyPl downloads, 7 out of 10 of them have a dependency conflict with another top 100 package. And this is actually super surprising if you think about it, because most of these packages are foundational and don't really have dependencies. So, but even though a good chunk of them don't have any dependencies at all, still 7 out of 100 of them will conflict with at least one other top 100 package. And the thing that's the big problem here is this is one of the few things where a user can encounter an error and be totally helpless to fix it. So it's kind of our job as library packagers to kind of take this problem seriously and try and make sure this doesn't happen to other Python developers. Off to Angela to explain why this actually happens.
Thanks, Brian, for talking about the introduction and motivation part. Next, let's look at the technical details behind the example that Brian just talked about. In this diagram, it shows that this application uses Apache Beam and TensorFlow. And both of the two packages depending on a shared dependency called protobuf. But as we can see that they are requiring different version ranges of their shared dependency. Apache Beam is requiring protobuf less or equal to 3.3.0, and TensorFlow is requiring protobuf greater or equal to 3.6.1. So when the user is trying to pip install these two packages together, they will see a warning message saying that the dependency requirements for the two packages installed do not agree with each other. And that's why the dependency conflicts occur. And if we look at the shape of this diagram, it looks like a diamond. So that's why this kind of dependency conflicts problem is called diamond dependency problem. And in here, let's look at the setup.py file of the Apache Beam package and the TensorFlow package. Using setup.py file is a common approach for Python library authors to set the dependency version requirements. And in the install requires part, we can see that that's where the protobuf dependency requirements is set. And that's how the dependency conflicts comes for that example. After knowing about the technical details, let's talk about the two common reasons that often lead to diamond dependency problem. As we all know that package owners often use a 3-digit version number to represent the version. And a question comes here. Who thinks that it is problematic to release a breaking change that only bumps the 3rd digit in the version number? Okay, thank you. Next, I will explain why it's not OK to do that. Actually, releasing breaking changes in the minor release is the most common reason that often causes a diamond dependency problem. In here, I will use an example, the OAuth2 client library, to explain that. In version 4.1.2, it removes an API that previously existed in version 4.1.1. And this is definitely a breaking change. And it is bringing 3 kinds of problems to the users. The first problem is that the version number isn't communicating the changes accurately. As it only bumps the 3rd digit in the version number, the user may still assume that the latest version is a backward compatible change. And if they just migrate to use the latest version without doing any code change, their code will be broken. And the second problem is that it makes it hard for the users to depend on the latest version of that library. Because the API was removed, the user will have to find a replacement or implement a replacement for the removed API, which could be a non-trivial amount of work. The third problem is that it makes it hard for the users to specify dependency ranges. Imagine if every future version of OAuth2 client released some breaking changes and just bumped the 3rd digit in the version number. The user will have no way to figure out whether the latest version is backward compatible or not. So that they will need to test each single version between the dependency version range to make sure every version in that range can work well with their code. And the testing part can also take a significant amount of time. Speaking of using version ranges to set the dependency version requirement, breaking changes in the minor release can also cause trouble to the user. In here, this graph shows that my package depending on 3 dependencies. We use ABC to represent the dependency name. And at the beginning, the user is using version pinning, which points to an exact version number to set a version requirement. They are using version pinning because their dependency is always releasing some backward incompatible changes. And using version pinning can make their code safe and won't be accidentally broken by the backward incompatible changes in the dependency packages. But later, the user will find out that using version pinning isn't that good because that can make their package incompatible with any other packages that require a different version number of the same dependency. And also, their dependency can get outdated very soon. So that they decided to change to use a version range. At this point, the user is actually doing all the right things, but they are still having trouble. The first kind of problem is that the user will have to use a very narrow version range. For example, greater than 1.3, less than 1.4. This is just slightly better than use version pinning. But as soon as a version 1.4 release comes out, their dependency will get outdated. Even if the user changed to use a broad range, there are still problems, because there will be too many versions to support. As we just mentioned, the user have no way to figure out whether the latest version is backward compatible or not, so that they will need to test each single version between that broad range, and that could be a lot of work. If the user decided to exclude the newer versions, a third problem will come, that they are not supporting the latest version. And this is actually the second most common reason that causes diamond dependency problem, because nearly all the newly created packages will use the latest version of their dependencies. And if your package doesn't support the latest version of the dependency, that means your package won't be able to work well with almost all the newly created packages. And also, the latest version of the dependencies can contain some important bug fixes or security fixes, and you don't want to miss out that kind of maintenance updates. Back to Brian to talk about the best practices to avoid diamond dependency problem.
So everything isn't hopeless, though. There's some things you can actually do to minimize the chance of your users getting dependency problems. The first one is the easiest, but potentially the most controversial. So Angela asked you this question before about whether bumping the least significant digit in a version number is reasonable when you have a breaking change. We all had this intuition that it wasn't. And there's a specification called Semantic Versioning that kind of describes what you should do instead. So the specification is really short. It's like 9 points that are like 3 sentences each. And I have the link there. But I'll give you the TLDR version. So you divide your version number into 3 numbers separated by periods: the major version, the minor version, and the patch version. So when you make a breaking change, you increment the major version and you reset the other digits. So in Angela's example, you would have gone from 4 point something to 5.00. And then I think kind of intuitively we would all think that that's more reasonable to introduce a breaking change. If you add a backwards compatibility function, if you add any backwards compatible functionality, you bump the minor version. So that's like adding a new feature or adding some new optional behavior. You can bump the minor version. And finally, if you do some sort of security or bug fix that without breaking the API, then you increment the patch version, so the least significant digit. And the nice thing about doing this change supporting this with your packages is you don't have to coordinate with anyone. You decide the versioning scheme for your package. You just do it. You don't have to coordinate with any other packages in the Python ecosystem. And it also, if you advertise that you're doing this, it's also a clear signal to your users what the guarantees you're offering are. So you've probably seen on some like PyPl and GitHub pages, it'll say like, we use SemVer. And that's just telling the user that they can count on this behavior. This is an old joke you can just read. So there's something called Hiram's law, which is basically if enough people use an API and you change it, it doesn't matter what the change is, it's going to break someone. Because people will start depending on every bit of behavior that you offer. And a lot of people object to SemVer because they say, oh, you can't really be backwards compatible. And if you think that way, I think you're just letting the perfect be the enemy of the good. You can, if you remove, if your API offers one function and you change its name, that is clearly a backwards incompatible change. You will break every single user of your package, and you should bump the major version. If you change some documentation string in your source code, and that breaks people, I think that's on them, not on you. So just try and do the right thing, be reasonable, and I think things will normally work out okay. Back to Angela.
Brian just talked about using semantic versioning. Although with semantic versioning, we can safely bump the major version number to release some backward incompatible changes, but it is still not recommended to do that. Because that will create an API churn. API churn is the backward compatible changes that includes removing an API, renaming an API, or changing the parameter list of an existing API. All these three kinds of changes will require the user to do some extra work to refactor their code in order to depending on the latest version of your package. In here, this diagram used TensorFlow as an example. As we all know that there are tons of users using TensorFlow. And imagine if TensorFlow decided to release a breaking change. And if the user just upgrade to use the latest version without doing any code change, their code will be broken. And they will need to refactor their code in order to use the latest version of TensorFlow again. And if the owner of TensorFlow keeps releasing backward incompatible changes, this cycle will happen over and over again, which creates a lot of extra work for the user. So package owners should avoid creating API churn too often and try to minimize the cost for the user to use the latest version. For example, if a package owner is going to rename an API, they can still keep the old name of that API, but mark it as deprecated. So if the user continues to use the old name, they will receive a deprecation warning. That can allow some time for the user to migrate to use the latest version instead of just break their code. Back to Brian to talk about using version ranges.
So this is plowing on with the machine learning example I was using before. So let's imagine I'm doing some machine learning stuff, and I'm using this nice add-a-net package. It's a Google package, and I'm using it. I'm building my model, and now and I'm just showing you the setup file just for no particular reason. And I developed my model, and now I want to export it to Core ML, which is Apple's machine learning framework, because I want to use this library on my iPhone. So I install Apple's Core ML tools. But Apple and Google have conspired to screw me over here. So they both demand a very exact version of 6 it's not possible to satisfy that constraint. And this 6 is a very compatible package. There's no reason why anyone needs to depend on an exact minor version number. So what you should try and do, or what they should have done, and what you should do when you're doing your own packages, is support a reasonable version range. So 6 doesn't, as far as I could tell, 6 does not support semantic versioning. So I actually had to go and look at their release history to see what kind of compatibility 6 provides with versions, and it looks like they've basically never released a breaking change. So in this case, we can just say, look, I need this version, but any version after that is also fine. And if both packages had done that, now they'll be mutually compatible, and they'll probably be compatible with any other software that uses 6, that doesn't make the version pinning mistake on the previous slide. Now, it would have been even better if 6 had used SemVer, because then we can just add another condition. We can just say, I'll use anything after the version that I need, but I don't want to support, I don't know that I won't be broken with the next version bump, so I'll explicitly not support that. And then when version 2 of 6, if version 2 of 6 ever came out, it would kind of be depressing if that ever happened. Then you, it should be called 7 then. Then we could upgrade. We would change we would locally relax this condition, test, make sure that everything works, and then we could start supporting the greater than 2 version. So this does. Once you stop pinning versions, you do have a bit more of a testing burden. But it's not a big deal. This might look like goop if you don't use Nox for continuous integration. But Circle CI and Travis also support this idea. And the idea here is I want to test with every supported Python version of my package. That's the top line. And I want to test with the earliest version of all the packages that I depend on. So by default, if you pip install a package, it will install the latest versions of your dependencies, which is great. But for testing, you also want to make sure that you don't introduce a breaking change with an earlier version of your dependency. So if you look at the first line there, I have like Jinja 2 equals 2.9.0. That would be what I want to explicitly test with that version because my setup file has greater than or equal to that version. So I just basically, I've called this compatibility test. In my compatibility test, I just install that early dependency version, and then I just run my tests as normal. So this will ensure that I don't accidentally introduce a regression with a version that I claim I support, because I don't develop with old versions typically. Back to Angela.
Brian just talked about using version ranges. Using version ranges is good because it can prevent the dependency version get outdated very soon. But we will still need to update the upper bound of the version range to include any future version number that isn't included in the version range before. In here, this example talks about Apache Beam and Google API Python client. They have a common dependency called http-lib2. And in here, it shows the relationship between the 2 version ranges of the 2 packages. The blue part represents the Apache Beam's requirement. And the orange part represents the Google API Python client's version range requirement. And as we can see that there is a latest version of http-lib2 that's 0.12.3. And the latest version falls into the orange part, but isn't falls into the blue part. That means the that means the upper bound of Apache Beam isn't including the latest version. And there's a question. Will pip install a version in the overlapping range? Actually, let's talk about it. If we do pip install Apache Beam and Google API Python client, the installation can happen successfully. And pip freeze shows that the actual version of http-lib2 get installed is 0.11.3, which is the upper bound of Apache Beam. And it satisfies both the 2 packages requirement. But what will happen if we switch the install order, like pip install Google API Python client and Apache Beam? There will be a warning message saying that the version of http-lib2 cannot satisfy the requirement of Apache Beam. And pip freeze shows that the actual version of http-lib2 get installed is 0.12.3, which is the latest version. And this is because pip is resolving the dependency version on a first-come, first-served basis. So whether there will be a dependency conflict depending on the pip install order. That's why, as a library author, we should support the latest version of the dependencies, because as the example shows, the users will be very confused if they see a dependency conflict in that case, because most of them don't know that pip will resolve the dependency version on the first come, first served basis. And also, as we mentioned in the previous part, newly created packages will certainly use the latest version of the dependencies. And that's important for your package to work well with all the newly created packages. And also, it's important to pick up the bug fixes and security fixes in the latest version. Here is a summary of the 4 best practices we just talked about, which includes using semantic versioning, avoid API churn, support as large as a version range as possible for your dependencies, and also support the latest version of your dependencies. That's all for our presentation.
Oh, sorry, go. Thanks. I was going to ask if there are any questions, but it looks like that's being handled for us.
Is this on? All right. So we have some time for questions. Please, if you have a comment, meet them in the hallway. If you have a question, now's the time to ask.
Yeah, if anyone wants to fight over whether semantic versioning is a good idea or not, we can talk in the hallway.
Hi.
Not in the back.
I just had a quick question. Does that pip install order matter in a requirements.txt file as well, or is that only on the command line?
You mean in the requirements.txt file?
Yeah.
Actually, if you use the requirements.txt file, the actual install order is arbitrary, and you don't have enough control for that.
Okay, that's what I was thinking. Thank you.
That's actually pretty mind-bending if you think about it. So the order that your dependencies are installed if you use requirements is arbitrary. So theoretically, you could install the same requirements file twice and get a different set of dependencies installed. That's what the docs say. It's not true in practice, but that's what you should rely on.
Hi. So I was wondering how automated dependency management tools like PyPl fit into this framework, I guess. Like, are they still useful?
You might have to be a bit closer to the mic. We
sure.
can't hear you.
You didn't get that. Okay. I was wondering how automated dependency management tools like PyPl fit into this.
There isn't really a tool for dependency management, but if you want to check the dependency version in your virtual environment, you can run pip check. And if there are any dependency conflict, there will be some warning message print out.
Can I add one thing to that? If the user so if you're thinking about this as what you should do as a package author, it doesn't really, if there is a tool that will do fancier dependency management, I think you still shouldn't rely on that because most people are still going to use pip and they're still going to hit these issues.
So you talked a little bit about how pip isn't the greatest at dependency resolution sometimes, but do you think there's anything about the way Python does dependency management and packaging that makes the impossible conflict more common?
Yes. So one problematic thing in Python, and I'm not a packaging expert, is source distributions. So you don't know, like in general, when pip is downloading a package, it doesn't know its transitive dependencies until it's downloaded it and run the setup script that's in it. So like kind of at the time that it's doing dependency resolution, it could have already downloaded the package, had to run it to check what the next level of dependencies are. If you had, say, wheel only, like if Python only supported wheel, then you could just, like the PyPl API actually will tell you what the dependencies of wheels are without running any code because that's just known at package creation time. And then you could have more sophisticated tools that just, they make some API calls and then do this resolution. I actually was kind of an advocate of that until I started talking to other people who hate wheels for other unrelated reasons. So I don't know what the path forward here is.
I'm afraid
a lot of
we're
people
out
aren't.
time.
Oh, sorry. Oh.
I'm afraid we're out of time. So if we could move all questions out to the hall. Thank you very much, Brian and Angela.